All right, so let's move on to our third speaker tonight, and that is Sashko Stubailo. Since graduating from MIT in 2014, Sashko has been involved in all of the major Meteor releases and has worked on some other projects as well. He was one of the authors of the Meteor Guide, which you can find at guide.meteor.com, and worked on Meteor's React integration as part of 1.2 and Windows support as part of 1.1. He's also been very active on our forums, where many of you may have run into him. Currently, Sashko is the tech lead on the Apollo project, the data stack for modern apps. Tonight, he'll tell us a little bit more about the Apollo project. So everybody, please welcome Sashko.
Yeah, so today I want to tell you a little bit about a new project we're working on. You could call it the next big project of Meteor. We just finished up, well, I wouldn't say finished up, but we just launched Galaxy, and I think the next big exciting thing is going to be Apollo. And for some of you, you might be aware of what we're doing already. We had a couple of blog posts, we have a GitHub repository, a lot of stuff like that you could have kept up with. And I imagine for a lot of you haven't heard of Apollo yet, and so you're wondering what it is. So this time, I'll start from scratch. So if you've never heard of it before, you'll find out what it is. So Apollo is the data stack for modern apps. Meteor includes the data stack. Apollo is the next generation of that data stack inside Meteor. And we'll talk about what that means, and you'll know exactly what that means by the end of the talk. So you're here at Meteor Night. You're probably familiar with Meteor. And by the way, congratulations to the Meteor team on the awesome 1.3 release. This is kind of what I wanted since I started using Meteor. It's mind-blowing. Anyway, Meteor does a lot of things. When Meteor started roughly 4 years ago, the JavaScript world was a totally different place. Client-side rendering was just becoming a trendy thing that people were like, should I be client-side rendering? I don't know. Now it's the thing that everyone does. Writing JavaScript on the server was also pretty crazy. Node.js was just becoming a thing. In short, to make Meteor a great developer experience, you needed to build out a huge amount of infrastructure around everything just to be able to get an app off the ground entirely in JavaScript. But I think personally, the most exciting part of the Meteor developer experience has always been the data system. Because even today, when you look around, there's really great alternatives for a lot of the parts of what Meteor started out with. For example, you can use React for the view layer. There's all different kinds of routers. There's different kinds of build tools, languages that compile into JavaScript, stuff like that. But only very recently have we started seeing tools and frameworks that revolutionize data loading in the way that Meteor did even back when it first came out. I think the main achievement of the Meteor data system was making the client-server divide a lot less of a burden. The same way that you can run the same code on the client and the server with JavaScript and isomorphic build tools and stuff like that, Meteor made it so that you could sometimes pretend like your data was both on the client and the server, even though it wasn't, which meant that you didn't have to constantly worry about getting your data from place to place. So let's talk a little bit about, in detail, what made Meteor's data system so different. Oh, there's some animations. OK. This is a great slide template that Dom made for us. So before Meteor, people were likely doing imperative data fetches. They were saying, man, I'm trying to render this part of my UI. I probably want to fetch some data right now. So you would call a function that's get this endpoint. You would put it somewhere in your component. Meteor made that all essentially declarative, right? Instead of saying, I want to fetch this data, you say, I'm interested in having this data. And then Meteor would push the data to the client for you using subscriptions, right? You could keep open as many subscriptions as you wanted, read from them at will, close them when you're not interested in them anymore, use tools to preload data before you need it. And that was much easier, I think, in Meteor than other systems. Also, for your API, instead of having a list of endpoints where you just call a function that calls a URL, you get back a random JSON blob of data, who knows how nested it is or what's in there. Meteor came built in with the concept of the identity of objects, right? Borrowed from MongoDB, the fact that every document in your database has an ID, right? So when you're using your data on the client, it wasn't just reading a JSON blob. It was querying a set of collections by ID or by different queries, so you could feel like you were really in control of your data, and it wasn't just whatever the backend happened to give you. And the last thing was, instead of making independent requests, right, each time you load a new part of the page, you load a new part of data, you had a stateful client-side cache, which meant that you could be aware that the client was keeping track of all the data that it had. And so if you go back and forth from one page to another, you wouldn't necessarily be loading all the time. You might be able to reuse some of the data you loaded before. And so the question is, how can we take some of these, what I believe to be the core benefits of Meteor's data system and kind of Meteor itself, and bring it to everyone. And when I say everyone, I mean literally everyone. I mean people who are writing their backends in Go, people who are writing their front ends in Swift, people who don't have reactivity in their apps, people who are using Salesforce and building UI on top of it. So Apollo is the idea that we can take a data system like Meteors and make it work in almost any type of application, and take the legendary, neat developer experience that bridges the client and server and make it work without compromises, right? Because right now, when you use Meteor, you're saying, I want this great developer experience, but at the same time, there's situations where you wouldn't want to use Meteor, right? Like, let's say you're writing a static website, like maybe the data loading stuff isn't as scalable as you would like it to be. And so how can we make this happen? So the more we thought about this, the more we realized that we needed a new way for the client to specify its data requirements. So in Meteor, the client specifies its data requirements currently using a set of subscriptions and then using a set of MongoDB queries. But there's a couple of reasons why this isn't optimal when your database is not MongoDB. I mean, the obvious reason is, why would you query your client-side data in MongoDB if you're querying it using SQL on the server, or a REST API, or the AWS SDK, or something like that? So the first thing we needed is a query language that was decoupled from your backend data services. And the second thing is, we needed a more semantic way to tell the server what data you need. Because right now, you just get to call a subscription, and you pass in some arguments, but the server at the end of the day decides what fields you actually wanted. And there have been some advancements in this, right? There's like publish composite, which are some packages that let you send a whole bunch of data that's relational and stuff like that. And those are great. But we really want to give the client the power to ask for exactly the data it needs. And so that's why we decided to go with GraphQL. And I think if GraphQL didn't exist, and thank God that it does exist, we probably would have had to invent something like it. But thankfully, the good people at Facebook came up with it for us. So just a super quick crash course on GraphQL. If you haven't heard about it, which I think a lot of people haven't, it's basically a nested query language that maps onto a set of functions and APIs on the server. So you essentially pass the shape of the data that you want and the kinds of objects that you want from the client. So the thing at the top right is the query you would pass. And the server resolves it to an object that is shaped exactly like the query that you passed in. And you can see that there's some nested objects in the query and in the response. Those can be traversals to entire different objects in your backend, right? So if you have a user and that user has a profile picture object, this field might be traversing to a different collection in your database, or maybe a different backend service entirely. Or it could be the GitHub API, like who cares? It can be anything you want. And so this is just a quick primer to understand the rest of the talk, but you can learn more both by reading on the GraphQL website, and also we have a Medium publication where we've been posting a lot of stuff about easy ways to learn GraphQL. And one last thing before we jump into what actually Apollo is, because there's kind of some abstract goals for it, is the importance of having clarity about how your application is working. Meteor has often been referred to as magical, or something where you use it and you say, wow, like how did that happen? Right? You go through a tutorial, you're like, I clicked the button over here and on this client it changed. Like, that's crazy. And that's really, really cool. And I think that's something that we want to maintain. I think the thing we want to add on top of that is a really easy way to get insight into exactly what's happening. So you don't necessarily want to build all the parts of your stack yourself, right? That would just lower your productivity. But at the end of the day, you want to feel as if you could have. Right? You want to feel like, if I wanted to build this from scratch, I could, because I know exactly how it works. I'm not going to, because the Apollo version is much better, but you could. So let's go into what it actually looks like when you have your app like this. So this is kind of a diagram of what a big production app would look like on Apollo. Let's be clear, if your app is very simple, you just have one database, one client, the diagram will obviously be much simpler. But the point is, we're thinking ahead to the larger apps, the scalable apps with lots of different backends and frontends. And actually, if you worked on an app before that has a bunch of microservices, REST APIs, a bunch of different clients, you might actually be familiar with this diagram, because a thing that a lot of people are doing now is building a thing called an API server, or a backend for front end, or BFF. And so you might imagine this box in the middle. Sometimes people build a Rails server that takes in all their microservices and exposes exactly the kind of API that their UI wants. But that doesn't work very well, because it turns out that when you're using something like a REST API and you want to minimize the number of requests you're doing, you want to make sure your data fetching is very efficient, you need basically very specific APIs for every single one of your UIs that you're writing. And sometimes your backends don't give you the data in the shape that you want. And that's where GraphQL and Apollo come in to make that super easy for you. So we've seen what GraphQL queries look like. We've seen what the general architecture is. We have some clients, some servers, and a proxy layer in the middle that is running on the Apollo server. And see what happens when you send a query from the client. So here's what happens. The UI will declaratively specify what data it wants in the form of a GraphQL query or set of GraphQL queries. The Apollo client will diff those queries against the local data that it has in the cache, much in the same way that you might have some data in Minimongo already today in Meteor. It will take the query that represents the data you don't yet have and send that to the server. The server will aggregate the data from the different services that you need to access, whether those are APIs or databases, send that result back to the client. The client will update its cache and deliver the result to the UI. And so from the point of view of the user interface, it's as if it just asked for some data and then it got it. But there's all the machinery going on under the hood to give you the same beneficial experience from Meteor that you get from being able to pre-cache data, preload it, manipulate it on the client, and do stuff like that. So let's make just a more detailed comparison between DDP and what we'll see with Apollo and GraphQL. So in Meteor, you have to first subscribe to your data, then query it on the client, right? You first call a subscription, then you pass a Mongo query. In Apollo, you just query it and you get the data, and the cache works silently under the hood. In DDP, in Meteor, the server decides what to send. In Apollo, the client decides what to request by sending a GraphQL query with the exact shape of the data it needs. In Meteor, the reactivity comes from live database queries. Right now, we have a very fancy component that watches MongoDB for changes and delivers them to the UI. Unfortunately, it only works for MongoDB. So in Apollo, the reactivity will be built on top of a request-response model, which means that if you can build a function that fetches the data from your backend data source, we'll figure out how to make it reactive for you if you want to. But if you don't want to, it doesn't have to be reactive. In Meteor, the schema lives in something like simple schema in your user code. It's up to you to provide the schema on top of MongoDB. In Apollo and GraphQL, GraphQL has a schema built in inherently. You know exactly what data your server can give you just by writing that API in GraphQL. And then there's a couple other things, but the most important thing is Meteor gives you a database query language to access your data on the client, whereas in GraphQL with Apollo, you have an application level query language, which is designed not for the needs that you have when you're fetching data out of a database, but for the needs that your UI has when it's fetching data from a server. So let's go on to what we're actually building, right? It's still kind of a 10,000-foot overview of the architecture. So, I wouldn't want to get into this without talking about what a lot of really smart people have already done, mostly around different tools about GraphQL, Relay, stuff like that. So all the stuff that I talked to you about just now, about diffing the queries and loading only the data you need, Relay actually already does all those things. So Facebook has created a really great template for a very smart library that does a lot of this stuff. Facebook also has some great reference implementations for how you might be able to implement a JavaScript GraphQL server. And so our goal is to stand on the shoulders of giants, take all the stuff that we think is really, really awesome, and combine that with our experience building really awesome developer experiences, the thing that got me to want to work at Meteor when you use it, and it's just so much fun that you want to keep building stuff. And we want to combine these to make using GraphQL and Apollo in your app a total no-brainer, whether you're writing a native app or whether it's a JavaScript application, whether it's in Meteor or you're using Webpack. We want to make Apollo the right choice for you. And so here are the first two components that we're building. The first one is the Apollo server, which my colleague Jonas is working on, and you can read his posts about this again on the Apollo Medium publication. It's going to be a super simple GraphQL translation layer that you put on top of your existing backends. So, like I said, you can fetch from as many backends as you want. So we want to make the most natural way to convert a set of microservices, a set of external APIs, and a set of databases into a GraphQL schema that you can query from the client. Whether or not you use the Apollo client, whether you use Relay, whether you use Airnode as Loca, or whether you use a simple post request, it doesn't matter because this is just a generic GraphQL server. It'll let you have a declarative schema so you can, at a glance, decide exactly what data you can fetch from the server. It'll have some translation code, and it'll have a standard GraphQL execution engine. And you can, if you're interested in this, check out our GitHub repository and contribute at apollostack/Apollo server. And the next part that I'm working on right now with lots of great help from contributors in the community, people are really jumping in and helping us out. It's a really light client that can be incrementally adopted in any application. And so what I mean by really like is that it does all this caching, optimistic UI, pagination, all the stuff that you love in Meteor and more, but in a way that can be adopted in any app you're building. First, only in JavaScript apps, but later also in native apps built in Swift or Java. And it has a razor-sharp focus on transparency, simplicity, and ease of debugging. You want to know exactly what queries are being made, how those queries got generated by your UI, and what kind of impact that's having on your database queries and APIs on the server. And that's something that I actually haven't seen in any system yet, because Meteor gives you the magic, but it doesn't always give you the best insights about how it's working. And this is something we're working on at Apollo, the Apollo client repository, right? They're not very creatively named, so that's good. And so basically, this is just a quick introduction to what we want to build, how we're getting there, and what we're doing right now. And I think that the goals that we're trying to achieve are really, really exciting, and I hope that I can come back to you 5 or 6 months from now and say, no matter what app you're building, you're going to get a benefit either in performance or ease of development or debugging if you switch to Apollo. And please follow us on Twitter or GitHub, or check out our Medium publication where we blog about various things related to GraphQL or Apollo, and we're always looking for contributors. So please let me know. Thank you.
Questions for Sashko?
Come on.
Yeah, what's your proposed timeline? I mean, so in terms of when you think you'll have one or either one of these first two pieces complete? Like, what do you guys target?
So the question is, what is our proposed timeline? When do we think we're going to have 1 or 2 of these pieces that we're building first? And it's a very aggressive timeline. We actually expect some of the people who are contributing to this library to be running in production next week. So this is not a vaporware. Actually, somebody called it vaporware on Twitter a while ago. It made me feel really bad about myself. But no, we're actually building real technology. It really works. I've built some demo apps with it. People are going to be running in production next week. And Meteor Night happened to be this week. If it was next week, I probably could have given you a better demo. But I'll come back and I'll have some really sweet stuff. Or if you follow the Medium publication, you don't have to come to Meteor Night to hear about that. Sam.
So with the Medium publication, the forums, Apollo, how many Sashkos are there?
Sam's asking, with all this social media stuff, publications, forums, Apollo, Meteor, like, how many Sashkos are there? And I like to think I just use my time in the most visible way possible. So I'm just very efficient. No, but there's only one. As opposed to Aeronota, of which there are thousands. So.
Updating the client-side cache, you said, or I read the design, it's supposed to have like an invalidation server. What's the status of that?
Yeah, that's right. So if you read the question is, I talked about updating client-side cache. We released a design for reactive GraphQL on our blog and also on GitHub maybe a month ago or 2 months ago that involved an invalidation server, which was a thing that piped messages from your server to your client to tell it when it needed to refetch data. So that's one of the things that we're not building yet, asking about timeline before. Right now, we want to focus on building a really seamless experience that is not yet focused on reactivity, because we think that the majority of apps will actually want to have reactivity for only a small selection of their apps. We're even seeing this from our production Meteor users today, that reactivity always has a cost, and you want to be judicious where you turn that cost on. And in Meteor, unfortunately, if you turn reactivity off, you actually lose a lot from the system if you start fetching your data with methods or something like that. So we want to make sure we have a system that works really, really well in a non-reactive state, and then put the reactivity on top of that. And whether that works through having a caching proxy layer or an invalidation server, we haven't exactly figured out what the best way is yet.
Databases are just going to support out of the gate.
The question is, what databases are we going to support out of the gate? The number one database we're going to support out of the gate is a REST API. Because in Meteor, we support a database, but it turns out that a lot of data sources out there cannot actually even be listed on a set of features, right? If you have some legacy service that you're talking to, or a payment system, or something that some guy threw together in Node.js once, there's no library that will help you fetch that data because all the data is totally unique. So we want to start out by building a system that lets you have totally generic data fetching without being coupled to a database, and then work up from there to have things that are optimized for specific databases that maybe reduce the amount of code you have to write, or maybe they give you built-in reactivity or something like that. But the main goal is that you could take your existing app with backend APIs, maybe it already even has a front end, and put this in the middle and get a huge benefit. One more question, yeah.
Is there any memory hit for using this over other methods to post and subscribe we should be aware of?
The question is there any memory hit is there going to be any memory hit of using Apollo over some of these other systems? I think no, because one of the main goals of the system, and we're maintaining this from our design documents in the past, is that the server doesn't have to keep track of almost anything. In Meteor, the server has to know a lot of information about what data the client already has in order to send it only the data that it needs. In Apollo, the client is going to take care of that, which is going to come at the expense of sometimes using a little bit more network, but we think it's better to waste the network a little bit than to overwhelm your server with memory to store stuff. So yeah, the goal is actually that this would not require any more memory or load on your system than any REST API or HTTP request would. Cool, that looks like all the questions. Thanks.